Hi, very good morning to all the students. Hi, everyone. Can you hear my voice clearly? Yeah, now it's already week number 9, yeah? Monday, yeah? And tomorrow, we will be having a test, right, on 2 p.m. So today, we will do some revision on the pipeline, but you also need to do the revision for the programming and etc. Okay, so hi, everyone. Let me see who is here. Uh, First, we have Bunkia. As usual, Bunkia is always on the top. Yeah, yeah, because starting from the B, right, his first name. Then we have Chai Sim, Chun Wei, and Jinwen, and Brenda Gui, and Ernest, and also Tiong Le, and also Wen Yang, and Xu Pian, and Yu Yang, and Zelin. So this is our tutorial class. We would like to discuss about some tutorial questions. Can everyone hear my voice clearly? If you can hear my voice clearly, please drop me a message at the message box. Yeah, so okay, thank you, Shipian, for responding. So let's uh, do the revision number 2. This has been discussed during the previous tutorials. That's why the answers are all here. But let's try to do it yourself. Yeah, I will show you the answer, but let's try to do it yourself. List out let me close the answer first here. Okay, so list out 5 micro operations in a Mips processor. So can you please do this question? Let's say in 5 minutes. Yeah. So, but I think it's better for you to try to answer it at your own Jamboard, right? That's why I will be creating a Jamboard that you can write yourself. Yeah. So I will just show yes, the answers are over there, but you can write at your own Jamboard. Try to do the revision throughout this hour. Yeah. By the way, any question you have for your tomorrow test that you want to ask me? Yeah. There will be 4 small questions. 4 small questions. You will be able to answer it within an hour. Yeah. So I'm sending you the Jamboard. Please answer this question. You can join the Jamboard and answer this question. List out all 5 micro operations in a Mips processor. Yeah. So as you can see, inside the pipeline, we have a lot of stage, right? We have 5 stages, including the fetch operation, operand decode, and then ALU. What else? Memory access, and then write back, right? So you must be able to write all this, yeah. Or you draw a diagram to show it. Yeah. Let me copy it. Copy, and then I will paste over here. List out all 5 micro operations in a Mips processor. So please do this. So because this one is for the this is revision 2 related to pipeline. Pipeline. So these are all 5 micro operations. What are those operations? Please put over here so that you can answer. I give you like a few minutes or 3 minutes, and then see whether you can answer it. What are the 5 micro operations for every single of instructions? Let's go and find your lecture notes. For tomorrow, that will be open book, but not open internet. Yeah, just open your lecture notes, any book you want, but do not search Google or any other materials. just can use your lecture notes. Yeah, you can see a lecture notes, you can see a books, you can see a tutorials. That's it. Yeah. Don't search internet. Yeah. So you will be tested to write programs, to write serial codes, to do pipeline. So what else? Performance. All those four things you must know. Yeah. You list out all the five microoperations. Maybe you just list out maybe enough. Just list out these five operations. That will be enough. Yeah. Okay. Good. You can see Y here. So who is this Y? What's Yao Ting? Okay. Thank you, Yao Ting. So very good. Okay. So a good try. So let me see what are those things. There are actually five micro operations in a Mips processor, which are these five. We have the instruction fetch. So first you must have the instruction fetch. After that you have the instruction decode and register rate. Instruction decode mainly. And then we have the execution of operation or calculate address. Sometimes they will put the ALU over here. And you have the memory access, the MEM, and then write the result into the register. Depends which type of instruction. So basically, they will do the relevant operations, micro operation during a certain stage. Stage 1, 2, 3, 4, 5. So that's why in your Pips pipeline diagram, you can see all those five items. So these are the five stages that have been pipelined so that they overlap one to each other. Yeah. So this is the first question. Very good. Let's see a big round of applause. Okay, very good. So next. Yeah, this will be the answer. Yeah, list out all five micro operations. We have instruction fetch, instruction decode, register fetch, execute, address calculation, memory address, and also write back. So these are the five stages. Let's go to the next question. You do see the answer first. Let me copy first. Copy. Then I go to this one. Question 2. Draw a pipeline diagram without any hazards for 3 instructions. So you must know how to draw a pipeline diagram like this. You have a pipeline diagram, one overlap the other. Then try to draw it, a pipeline diagram without any hazards. You can look at this in your lecture notes. Yeah, you can look at it at your lecture notes. So let's do the revision at the same time. Let's see how to draw a pipeline diagram. So a pipeline diagram is actually overlap to each other, yeah. So this is a pipeline diagram. And let me show you the pipeline. So then you can actually draw the pipeline diagram at here as a practice. Yeah. Let's wait a while. It's still running. So this will be the pipeline diagram. So we have the instruction one, instruction two, instruction three, instruction four, etc. So there are many instructions here, one, two, three, four, five. So put instruction one, two, three, the draw, the first instruction fetch, then register, instruction decode, register decode, and then we have the ALU, and then memory access, and then write back. All this you can actually write it back. So of course you can see the words here are different, but actually they are referring almost the same thing. Yeah, execution, all this stuff. You can draw like this also if you want. Yeah. So let's try to draw it. You can draw like this, or you want to draw like this also can. Both of them also acceptable. But some people do like to draw. Yeah. But if you draw, then maybe a bit nicer, then can, yeah, so good. If you don't want, you can put like this, the diagram. And it's more like a table, right? Yeah. So let's do this. Yeah. You can write it, you can do it on a piece of paper, then you catch a picture, load it. And make sure you do it yourself at your home. So for tomorrow, you have to turn on your video all the time, but turn off your. Then I will give you extra maybe some time to upload your papers, just like your final exam. Now you learn how to draw a pipeline diagram. Uh, yeah. without any hesitation, in the pipeline, like to destroy stage one substance here, here, chapter label, execution, memory, that. And then this will be the answer, three of them. Yeah, three of them. Because each instruction has stages, so they are overlapping each other. Yeah. Yeah. To put here, we still have another three questions. Anyone? Yeah, anyone can give your answer. Just sketch a picture and then put it here. Yeah, you see on the line. Yeah. Okay, you got that? With about 14 motion for honest. Please your answer. Yeah, if not there, okay. Uh, so most of you already need okay. Then you're shy, you don't want to do it. Okay, right? So let's put here. Okay, Shipen, thank you, Shipen, for answering this. Yeah, thank you, Shipen, for answering this. Uh, I think it should be Shipen, right? Because I see a dark blue writing there. Yeah. So, very good. Let's get this to Shipen. So this will be the line. So here you can put some instruction one, and then instruction two, instruction three. Yeah. Here you can put in the clock cycles. Clock cycles, maybe you can. Okay, let me show you. Okay, very good, Shiken. It's a very good trap. Okay. So here we see clock cycles. Clock cycles. Of course, you can put it 1, 2, 3, 4, 5, 6, 7. Okay. So all these are the clock cycles. So let's get a possibility for this time. Okay, the question. Yeah, the question is let me see. This one a bit tougher. Let me now you are ready to do the diagram without without any hazards. But now you do have a hazard. So now let's try to solve this and drawing a new pipeline. I'm going to place it over here. The question. So please answer this within 5 minutes. Try to redraw your pipeline diagram that you have already done just now. Then you use draw a pipeline diagram for the following instructions. Load the word, this one from the memory, add 0, the memory address inside R2. Then add 0, then you go to R1. Okay. So the R1 is needed in order to do the second operation, which is start R4, R1, R6. So because R4 equals to R1 minus R6. So assume that the data has happened register R1. Okay, data hazard. Use a store method. So what you do is, because in the lecture notes you can see we have a store over here. So yeah, so in case you have this type of problem, so you can put a store there. Yeah, store there. Then you can see why is store, because this instruction actually need a memory access. The memory access only happen at stage number 4. So after stage number 4 of the first instruction only, you can do the ALU operation for the stage number 3. Sorry, for this instruction number 2. Yeah, stage number 3 for the instruction number 2. So let's draw something like this using a pipeline diagram. Yeah, let's try to do this. Yeah, basic. Yeah. So let's draw a pipeline diagram, including a stop, because let me repeat again. The load word can only complete during the memory access, because it's about the accessing the memory to R1. So after stage number 4 only, then this operation can complete the stage number 3. So this stage number 3 can only happen because it's subtract, right? You need stage number 3. So stage number 3 only happen when you after you have done the stage number 4 here. That's why you need a store in between. The answer is just like this. Let me show you a little bit. You have to put a store before the memory access for the first instruction. Let's do this and then put an answer over here in 5 minutes. Yeah. Let's try to figure out how to draw the pipeline diagram. Anyone also can do? A nurse also can do. Can say also can. Yeah. actually cellular. Yeah. Yeah. Yeah, see, and you know who is doing this? Anyway, I know who is doing this. I just see yeah. You see, okay, what? Okay, thank you for writing this answer. So, very good. Yes, correct. The first instruction, this is actually a mixed instruction. This one do the mix. You can see if in instruction from the memory to the instruction register. So first instruction is controlling, then the control transfer from the memory to the this instruction register. After that, you put the instruction. Yeah, only execute. But this operation only complete during the memory. Please need the memory access. It doesn't write back. It doesn't write to the memory. So that's why you need memory access. Stage number 4, you complete the operation, but they will also go to last one because all instructions need to go to the last one according to Mips processor. So the subtract R4 equals to R1 minus R6 will be completed, can only be completed after the memory access. That's why you have the instruction fetch, instruction decode. The execution, you haven't waited, you haven't, your data you wait, haven't yet. R1 still at this stage. So there's no operation can be done here. So you stall it first, then only you do the execution at the stage number 3 here for instruction 2. Then execution for stage number 2 only can happen. In this case, after that we have the memory access and then write back. But according to Mips, even though you don't use this, they still go through the 5 stages. Mips is standard one. All of the instructions will go through 5 stages no matter the need or not. Yeah, this is the Mips architecture. Of course, other computers might have different kind of design, but for Mips, it's very standard. 5 micro instructions for all the instructions. Okay, very good. Let's see a bit about to thing. So now you know how to draw a pipeline diagram. So next, without further ado, yeah, any question you can just ask me at the text, or you can actually turn on your mic. I don't know, you can turn on your mic anytime. Yeah. So let's do this. Now we are talking about, just like talking about the data, is it? But some data haven't been yet. Yeah, now go to the, okay, make my, do you want come with that? I talked about the data haven't been ready and the decision of the
Sir, your sound is not audible. It's choppy.
就准备呢。 Sorry, can you hear my voice now?
Sir, would you mind to turn off the video cam to reduce the data uploading?
Yeah, sure. Is it better now? Uh, Is this better now? Can you hear my voice clearer? Clearer?
No, still not good.
Okay, clear. That would be funny. Let me uh, go out and go in again. This signal,
Never mind,
then
sir.
you
It's
can.
okay already. Suddenly it's okay
Okay,
already.
really. Oh, suddenly, okay. Is everyone having the same problem or yeah? Never mind, I thought my can you hear my voice? Yeah, okay. So please do this. Yeah. So actually, question. So now, because I'm not sure whether you still can hear my voice or not. Okay, let's redo the order the following instruction with pipeline data hazard so that the hazard can be avoided. Yeah. So let's see. Previously we have all hazard, but now we are dealing with another hazard. Yeah. So this one also is a data hazard. It's a problem of this option is that we are subject to outside for so uh, we actually have the source of reference of instruction actually depends on the output instructions. So let's rearrange this. Yeah, rearrange this. Let's do this. Yeah, thank you. So let's do this. Yeah, let me see whether it's already ready. Yeah, already ready. Yeah, it's a bit slower. I think I better turn off my video. Yeah, rate order the following instruction with pipeline data hazard so that hazard can be avoided. There are two main methods that you can use to solve the problem. First, you use the uh, hardware method. The other one is you use the software method, which is a compiler. So let's rearrange this and write your answer over here. Yeah, I give you like 5 minutes. Can you hear my voice clearly now? Jiwan?
Sometimes good, sometimes bad.
Yeah. What happened? Yeah. We try to do it on the web, but now today we talk very less. Please do this question. Yeah. I'm not sure why. Suddenly. Yeah, let's spend 5 minutes to solve this problem. I can see the answer now. But just now I see a blue color only. Okay. You know who actually write this answer? Can you show me your name? Here, are you here? Here, thank you for your answer. Let me see whether the answer is correct or not. Yeah, thank you. So now, subtract R4, R1, R6. You continue and put this one at the end. Yeah, correct. You're right. Okay, very good. Let's give a big round of applause to you. Shipian. Okay, very good. We still have one more questions that we want to do. Anyone has any problem with using compiler to solve the hazards? If no problem, then we can go to the last one. The last one will be related to the pipeline also. This will be the last question. I want you to try to use list out 5 methods to control the hazards. Let me show you the answer. Questions. List out 5 methods we can use to solve pipeline control hazards. Basically, until now, we have already done some exercise on the data hazards. And now we are moving to the control hazards. Let's list out 5 methods to solve pipeline control hazards. Let's list out these 5 methods. Can just interchange line 2 and line 3. Yeah, so may I ask whether we can just interchange line 2 and line 3? Yes, it is possible. Yeah, but the safest way is to put it as very last one so that you are very sure, right? Yeah, you're very sure. Better we put at the last one. Later, because we don't know where the operation complete, right? It might complete at the right side. Instruction decode, register decode, ALU. ALU after that only memory access, then right back. Yeah, it's right back. Last one. Yeah. Yeah, so because it's last one, so you better put at the very end. Yeah. Hopefully it will complete already at the end. Yeah. Yes, it's possible. Yeah, thank you for your question. Okay, good. Thank you, Tiong, for your question. So now list out 5 methods to solve pipeline control hazards. I can see. What is a pipeline control hazard? Meaning that you jump, but you don't know where to jump. Okay, so you don't know whether the next operation will happen. How the next operation will be, because you don't know whether it will jump or not. You branch to another instruction or not. So there are 2 possibilities or more than 2 possibilities. How do you fetch the next instruction? Because you don't know what is the next instruction. You are not sure. So let's look at your lecture notes to see all those 5 methods. Last time we have already done the delay branch. I will explain the delay branch and also other things. So Xu Pian, okay, thank you Xu Pian for answering this. Yeah, very good. This is a store method. Next, we have the store method. Predict branch taken, predict branch not taken, delay branch, execute both paths. So these are the 5 methods that, so you can actually look at your lecture notes. So let's read carefully, using this time, read carefully because it will also help you during your final exam. If you read more now, then during your final exam, you will only, you don't need to read so much. At least you have understand half of them. So now, we have finished our tutorial, sorry, not tutorial, revision. Yeah, so you can actually refer to this Jamboard. It will always exist over here. So let's refer to this whenever you do the revision. So you can refer to all the available Jamboard for our course. Yeah. So that's all for today. Any question you want to ask me is tomorrow. will be your tomorrow will be your test already. It's about 2 p.m. right? Yeah. So for the compare assembly language format, which one is correct? Compare argument 1, argument 2, or compare argument compare? Oh, compare actually compare. Website source gives conflicting answers. Okay, compare this one. In order to answer your question, actually both also okay. Yeah, you can compare argument 1, argument 2, or compare argument 2, argument 1 also. Okay, if you only want to check whether it's equal or not. Yeah, because if this one A equals to 2 equals 2 equals to 1, actually same, right? Yeah, but let's say you want a greater than, less than, then is the sequence is very important. So Intel, let me pick 0, compare. Okay, so compare to operation, so you have to go to this. So compare, so this is a compare operation. Yeah, let's see compare to numbers. Okay, compare, let's go to see the compare. So this is the X6 instruction set reference. Compare AL with this one. So compare register. Let me see. Is there anything compared to operand? Yeah. So let's see compare operation. Do we have any? But usually the destination is definitely, let me check. Compare instruction Intel. Control flow. Let's see whether this one will solve our. Sometimes in we have to refer to the manual. So move jump wrong. Okay, compare. Superhand. Intel syntax is minuend, subtrahend. Yeah, for comparison between minuend and subtrahend, the comparison perform like this. So we compare jump equal, then no problem lah. Jump not equal. Jump above, jump if above. Okay, let's look at this. Jump if above. Load the EIP with specific address. If the menu end of the previous is greater than menu end is greater than the subtrahend, and greater subtrahend. So which are menu end? Menu end is here. If this one greater than this one, if menu end greater than subtrahend, so it will jump above. Yeah. So jump if above, if the first operand of the previous compare instruction is greater than the subtrahend, they have a special name. So yeah, it will jump. Yes. Yeah. So am I answering your question? Compare Rx and RBX. If Rx is more than RBX, then you jump above. Yeah. Brenda, have I answered your question? This one is for the Intel syntax. Then this one is GAS syntax. Yeah, it's a. Never mind, we just use the MASM. We don't use this GAS. Yeah. GAS, we have two types, so you see. One is two of them also x60 86 assembly. But for the MSM, we use the menu end first. But for the GS, what is this GS? Let us a bit. Yeah. So this one is we don't use we don't use is a different type. GUS is GNU S. Okay, what is this GNU? When we talk about GNU, because this is the assembly language. Assembly language is not something inside the computer. It's programmed by assembler, the software company. So let's say Microsoft, they say the first one is menu end, the second one is subtrahend. So we follow first one greater than the second one. But beside Microsoft, there are many companies in this world, especially got some company who Microsoft actually is a paid software. Any software that we want to use from Microsoft, they will charge us. But for GNU, they have a different, this GNU actually has a different mindset. They want to make the software free, free license. We have the GPL license. So that's why they have a little bit different. When they design, they use a different concept. Yeah. So of course, the Intel processor also sometimes run the Linux program. If you run a Linux GNU or the GNU license software, then you have to use a different syntax. So this one like this. So you can see, GS instruction generally have the form of like this. Move this one into this one. Yeah, you can see totally different. Totally different. Yeah, for the GS, for GNU. Yeah, but for us, we don't use this. This is just the different software only. We just stick to one, MSM, which we have learned in the class. So am I answering your question? Yeah. So it's compare argument to, yeah, correct, everything. Yeah, because they switch the source operand and also the destination operand. Yeah. So is there a full type assembly language syntax that we can refer to? Yeah, of course, there are many full set. Usually, full set, you have to get it from Intel website. They have the manual. But we don't use full set most of the time. We will learn from the website. So you can search X assembly language tutorial like that. Then we will learn from this. This is very, they are full set, but usually you can go to a tutorial point to learn. But nobody actually use all the instruction in Intel. You have to go to Intel handbook, all the handbook there, and also manual there. Then only you will learn. So at this if you learn all these basic instruction, that should be fine already for your case. Yeah. For all the instruction, yes. In Intel manual, yeah. They have to provide all the instruction set. Yeah. So you just learn according to all these. We have all the instructions. That should be fine already. Yeah. It's not easy. Yeah. And then useful resources, you can go and search. Yeah, I have Linux assembly and also NetBite assembly and also MSM. Yeah. Any more question you want to ask me? So don't worry about all the instruction. We have a few instructions, so search it when you want to use it. Yeah. Any question you want to ask me regarding your test? Yeah. Yeah. Okay. Thank you, Tiong Le, for sharing. So is that full? Yeah. Jingwen say I do found one. Yeah. So please follow Jingwen one also and Tiong Le one. So Tiong Le also here. Yeah. So there are many instructions there. We don't use all the instructions. There are many. Any question you want to ask me? So thank you for your sharing. Any question you want to ask me for your test? Oh, you have to say first. Then only I can open. And let me see how good is the instruction set. This that you have already shared. So if you have any question want to ask me, then you can ask me. So tomorrow we will be meeting around 2 p.m. right? Yeah. So by 2:30 we can start like that. Yeah. But I will give you the question like around 2:15. I can give you the question already. Yeah. A little bit buffer between before I give you the answers. So these are all instructions. Wow. Yeah, very nice. Thank you. That one, what Brenda asked is actually the manual and also subtract hand, because Linux and also Windows they have the different thinking. They think differently. Yeah. So they create something different. So we follow MSM first. Yeah, in case in future you involve in that one, it's very good exposure. So what Brenda asked is very good because in future if you meet this kind of code, or you think, oh, in the class I learned the wrong thing. No, because different software vendor actually has different design. Yeah, that's why all assembly actually have a little bit different in formats. Yeah, very good. Good that you know this machine code in case you need to debug some program that in future you will know how to do it. Yeah, one by one they also give you some many things. For very good. Thank you for sharing this. Yeah. So any more question you want to ask me, because now it's already 8:59, 58. If no question, then you may allow to leave. Thank you, Brenda. Thank you, everyone. So all the best for studying tonight. Tomorrow is open book only. Not open internet. Yeah, you can get your all the book ready. Don't search. Okay. Thank you. Yeah. Thank you, everyone. So all the best and in your revision. Okay. Bye. Okay. Thank you.